All right, so to start off our lesson, I do want each of us to practice filling out the unit circle because it's going to be very helpful for us during our test and when we're evaluating with the unit circle. So as you can see, I already labeled all of my degrees. I started by counting all of the middle tick marks, including the major axes. I counted by 45. So 45 plus 45 is 90. 135, 180, 225, 270, 315, and then back to 0 is 360 degrees. Then I counted by 30. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Okay, but what I do want to focus on is how to now write in the radians. So what we're going to do is we're going to count around the circle. I'm going to start with 45 degrees. So we want to memorize that 45 degrees in radians is pi over 4. Okay, so now I'm going to count around to every 45 degrees or every pi over 4. So this is 1 pi over 4. So this would be 2 pi over 4. So when I simplify that fraction, dividing 2 top and bottom, I get pi over 2. Then 3 pi over 4. 4 pi over 4. And the 4s are going to cancel to give me pi. Then 5 pi over 4, 6 pi over 4 down here, which is going to simplify when you divide out 2 top and bottom. You get 3 pi over 2. I'll box that one up. And then this is 7 pi over 4. And then last, when you go all the way around the circle, it's going to be 8 pi over 4, which gives us 2 pi. So we know that 0 or 2 pi is going to be over here in radians. So again, I just went around counting every pi over 4 for my 45 degrees angles. Now I'm going to go around every 30 degrees, which is pi over 6. So we have to memorize 30 degrees in radians is pi over 6. So this is 1 pi over 6, 2 pi over 6. When I simplify dividing 2 top and bottom, I have pi over 3. This is 3 pi over 6, which I already have simplifies to pi over 2. 4 pi over 6, which is going to simplify to 2 pi over 3 when I divide 2 top and bottom. Unbox these. There's 5 pi over 6, and then 6 pi over 6, which I already have becomes pi. This is 7 pi over 6. 8 pi over 6, when I divide 2 top and bottom to simplify, it's 4 pi over 3. And 9 pi over 6, when you divide 3 top and bottom, gives you 3 pi over 2. Then 10 pi over 6, when you simplify, gives you 5 pi over 3. 11 pi over 6, and then one full circle around is 12 pi over 6, which gives us 2 pi. So again, having this filled out is going to help you significantly on the test or on all your homework practice problems. So if they ask you about evaluating at 7 pi over 4, you just look here and you're like, okay, 7 pi over 4 means 315. If they ask you to evaluate 7 pi over 6, you just look here and 7 pi over 6 means 210. Okay, we're going to be graphing sine and cosine functions, and I've taught you all year long that no matter what the function is, if you want to make a graph for it, you can always create a table, and then filling out the table will give you some ordered pairs and help you plot your graph. So I'm going to show you how to make a table if you want to find y equals sine of x and graph. So what I'm going to do is I'm going to create a table, x and y. I'm going to write this kind of small because I'm squished for room here. So what I'm going to do is I'm going to plug in numbers for x. I'm going to start by plugging in 0. Okay, so if I want to find sine of 0, that takes us back to another lesson. So really quick, I actually forgot. We want to add in the special major axes and their ordered pairs. So really quick, over here at 2 pi or 360 degrees or 0, we have an ordered pair, 1, 0. So in the ordered pair, the first number is always your cosine, and the second number is always your sine. So over here it's 1, 0. Up here at 90 degrees or pi over 2, it's 0, 1. So again, 0 would be our cosine then, and 1 would be our sine. And then over here at 180 or at pi, we have the ordered pair -1, 0. First number is cosine, second number is sine. And then down at 270 or 3 pi over 2, we have the ordered pair 0, -1. So if you're asking me how I found those ordered pairs, it's because the very center where the x and y axis meet is the origin, where we have 0, 0. So if you go 1 to the right, it's 1, 0. 1 up is 0, 1. 1 left is -1, 0, and 0, -1. So those points, just so you guys know, should land exactly right here. But since I didn't really have a lot of room, it's 1 because a unit circle has a radius of 1. So that's just telling you right here, it's an ordered pair. So each of the major axes has that ordered pair. Okay. So back to this, I'm gonna find sine of 0. So we actually wrote that on here. If you look at 0, we have an ordered pair. So at 0, we have the ordered pair 1, 0. So at 0, sine is 0. So let me show you the work for that. I'm plugging in 0 for x. Sine of 0 equals 0. So my y is 0. Okay. The next thing I'm going to look at is where I'm going to get another nice number. I'm going to get another nice number for sine up here at the 90 degrees axis. So I'm going to put for x pi over 2, which means 90 degrees. When I put pi over 2, sine of pi over 2, I get what for my sine? 1. So sine of pi over 2 is going to equal 1. So there's another ordered pair that's going to follow my graph. Then go to your major axis over here for pi. Now we're going to plug in pi. If I ask you to find sine of pi, it's going to be 0. So if I plug in pi, sine of pi equals 0. And then the last thing we're going to, well, second to last thing, the next major axis, if I look at sine of 3 pi over 2, it's the second number, -1. So if I plug in 3 pi over 2, we get -1. And then I'm going to go around the full circle over to 2 pi. At 2 pi, my sine, again, is 0. So what we want to understand is this is going to take us one full cycle through our unit circle for sine of x. And we're going to call that our period later. That's what that's called for our function. So now what I'm going to do is I'm going to create the graph. So every time you create the graph, you're going to have 4 different, or actually 5 different points. So I have this is 0, okay? So 0, 0, I'm going to have a point. Then pi over 2 is going to be my first x. So at pi over 2, I have an ordered pair, or a point, up here at 1. Then my second x value was pi. I have a point at pi, 0. So we're going to write this is 0. So we put the point there. Then we have a point at my next x, which is 3 pi over 2. That's going to be -1 down here. And then at 2 pi, which is going to be at 0 again. So this, I understand, is very, very confusing. This is going to take a lot of practice, but I just want you to see where the shape of the graph comes from. Every single time you have a sine graph, it's going to cross through 0, 0, or for us, it'll kind of start at 0, 0. Even though it's not really starting there, there's a bunch of the graph happening on the left. So it's going to cross through 0, 0 every time for the sine, or the parent function of sine. And it's going to go through and go to here. So we have to know that sine and cosine graphs are periodic, meaning they're going to bounce back and forth and go on infinitely. So if I wanted to continue drawing this graph, it would just keep going on and on and on like this. Okay, so don't worry too much about being able to create the table. This is just showing you where the numbers come from. Okay, so I'm only going to do a table for this first one. And what we really need to understand from this is just a few things, okay? This thing right here, it's going to be our amplitude. So it's going to be from 0 up to where that graph hit, up where it maximized or where it was a maximum. It's called our amplitude. Let me write that right there. Okay, so in this case, we had an amplitude of 1. In case they asked us, we would be able to say we had an amplitude of 1. Okay, and then we need to understand another part of the graph. So this thing right here, so where it began and then where one cycle of it ended is called the period. So this is the period, and the period is 2 pi because it was 2 pi long. So period is 2 pi. Okay, so that is going to be our original sine function, because when we see numbers in front of sine or next to x, it's just going to be transformations of this original graph, but this is where it stems from. Okay, so now we're going to look down at the cosine graph. So this is going to be our kind of parent function for the cosine graph, where this is where our original cosine graph, this is what it's going to look like. So I'm not going to create a table. I'm just going to rely on you guys to memorize, okay? So what I'm going to do is I'm going to draw 1 and -1 on the graph, because that is going to be where my graph is going to be bouncing back and forth, just like in the sine graph. So the difference between the cosine and the sine graph is that our sine graph started at 0, 0. Our cosine graph is going to be starting at 0, 1. So the reason why is if I were to create a table and I found cosine 0, if I plugged in 0 for x, you would get 1, because cosine of 0 is 1. So that's where this point comes from, okay? And then I would put my 4 marks again, because I have a mark here, 1, 2, 3, 4, and then my 5th mark, okay? So for our original cosine graph, it's going to have the same period, 2 pi. So halfway is pi, half of that is pi over 2, and then 3/4 of the way is 3 pi over 2. Okay, so again, don't worry too much about labeling these. We just need to know this is what the graph looks like, but we typically don't memorize that. Okay, for us at least, learning this lesson in one day. So what happens here is that we are going to have a point here. We're going to have a point down here, a point here, and a point here. So look at the difference here between that sine graph that we did up above, because this right here is 1 period for our graph. This is 1 full cycle. Okay, so that length right there, and then just so you guys know, it does keep going infinitely. It just goes in that same motion all the way, and it actually goes to the left as well. So this is our period. If they asked us for this, we would say the period is 2 pi. And then our amplitude, just exactly the same as what we did with sine, is going to be 1. So this is the amplitude, and our amplitude is 1. So what it is that whole length of the graph, and it's divided in half, like the height, and you always divide it in half. So amplitude. Okay, so what I want you guys to understand is what exactly is going to happen now when we have some transformations, because now we're going to have numbers out in front that are going to change these graphs. But if we just memorize the shapes of them, all the rest of it might come in time. So sine graph starts at the origin, or passes through the origin, 0, 0, and goes here with a period of 2 pi. And then our cosine graph is not going to go through the origin, but go through 1, 0, or I'm sorry, 0, 1, and then do this same periodic type of graph with a period of 2 pi, amplitude of 1. So if we look at our original equations or formulas, we're going to have these. It's y equals a times, let me zoom in a little bit, sine of b times x. So what we want to think about is our previous lessons. You guys already know that the a is always going to be our vertical stretch or shrink. So if that number is bigger than 1, it's going to stretch our graph vertically. So that means right here, like if I had something like 4 sine x, so there's a 4 out in front of this, what it's going to do is it's going to take this and stretch it and make it taller. Okay? Or if I had an a value less than 1, then it would shrink it. So if I had a value out in front like 1/2, it would not have an amplitude of 1, it would shrink it down. Okay, so another thing we want to know about the a value is that a value is always going to tell you the period. Okay, so we're going to write that down. To find the period, or not the period, I'm sorry you guys, the amplitude. What's wrong with me? It's been a long day of note making over here at my house. Okay, our amplitude is always going to come from the a, and I think that like you can think of a value, a for amplitude. So whatever number is out in front is actually going to be your amplitude. But what you have to do is take the absolute value of it because it'll never be negative. Okay, so your amplitude is always going to come from that number. All right, now let's talk about the b value. The number in front of x is our b, and that's actually going to be our horizontal stretch or shrink. So if I had a number out here larger than 1, what it would do is it would stretch my graph horizontally, so it would spread it out further. Okay, and then if I had a horizontal shrink, a number less than 1, then it's going to shrink it down and put it closer together. Okay, so that's the difference for vertical and horizontal. But again, vertical we should understand. Horizontal is going to be a little tricky because we haven't talked much about that. But we do want to keep in mind that that b value is going to help you find the period. So remember, period was this length of the cycle. So for the graph, so period here is going to be the formula 2 pi over b. It's actually the absolute value of b, because b, if it's negative, you would just get rid of the negative. So you're gonna, to find the period, just follow the formula. It's 2 pi divided by whatever function, whatever number's there, and that'll tell you your period. Okay, so that is why, just to let you guys know, that for sine of x and cosine of x, which I should probably write that up here really quick, that the same rules follow for sine and cosine, sorry, for your a and your b. Same thing for cosine and sine. Okay, so for this one, we have an amplitude of 1 because the a value right here was 1. We just didn't write it. And then you had a period of 2 pi because the number in front of x was a 1. So using the formula, it's 2 pi divided by 1, which is 2 pi. That's where the period comes. All right, so let's put this all into play. Okay, so I know this is confusing. Just stay with me. We're going to review again Friday. So for this next example, we won't create a table, but we want to understand what's going on with what they present us. Okay, so first things first, we're going to want to understand that the sine graph is going to have a certain shape compared to cosine. So remember, the sine graph is going to go through 0, 0. Okay, but since this is 1/2, this is going to be a vertical shrink. So it's going to shrink our graph down, but more importantly, that is just going to tell us the amplitude. So always, this number is going to be our a value or our amplitude. So that's going to tell us how high, how tall our graph is going to go. So I'm going to put 1 right here and 1 right here, and then 1/2, because 1/2 is how tall my graph is going to go. It's going to bounce between 1/2 and 1/2 because of this value. So what I also am going to have you do, so every time you're going to graph, you're going to figure out amplitude. So step 1, figure out your amplitude, and then create these y values. Okay, amplitude is going to go between 1/2 and negative 1/2. Okay, so then your second step is going to figure out your period. So how am I gonna label this x-axis using those 5 tick marks? So to figure out the period, it's a formula, 2 pi divided by b. So whatever your b value is, you plug it in. My b value is 1 because there's no number in front of x. So it's 2 pi over 1, which is 2 pi. So I'm going to have that period of 2 pi. So let's go in and label. This is 0. You're going to have 1, 2, 3, 4, or a total of 5. 1, 2, 3, 4, 5. So this is going to be 2 pi over here. I probably could have spread this out. That was not good, and I don't have white out. That's all right. And then you have half of that would be pi, right? Half of pi is pi over 2, and then you have 3 pi over 2. So another way you can figure this out, you guys, is that it's going to be counting by pi over 2. 1 pi over 2, 2 pi over 2 becomes pi. 3 pi over 2, 4 pi over 2, which becomes 2 pi. So for our sine graph, we are memorizing that it's not, or that it's starting at 0, 0. So I'm gonna, or not starting, it passes through 0, 0. So this is what your graph is gonna look like. It's gonna go up here and then go back down. Go down and go back here. That is one cycle through 2 pi. Okay, and then you can just continue drawing your graph. That's good enough. This is good. So the sine graph, and then it's 1/2 for your a value, so it shrunk it down, and it had this period here of 2 pi. Okay, and then again, amplitude was 1/2. All right, so let's look at another one. So we have 4 times 4 cosine pi of x. So we have 2 steps. Every time we need to figure out amplitude and we need to figure out period. So we remember that this 4 right here is our amplitude. So I am going to go ahead and label my graph. The y value, it's going to go 1, 2, 3, and go up here to 4. So it'll go 1, 2, 2, 3, 4, -4. So it's going to bounce back between 4 and -4. That's because of our amplitude being 4. Okay, then pi is going to be our b value, which is going to help us determine the period. So that was step 1. Step 2, find period, which is the formula 2 pi over your b value. So it's going to be 2 pi over pi because my b value is pi. So 2 pi divided by pi is going to give me 2. So we're going to go for a period of 2, and then it's going to bounce back between 4. This is our cosine graph. So we want to remember that it doesn't go through 0, 0. What happens now, it typically would go at 1, 0, but because of the 4 stretching it, you're going to have a point up here to start. Okay, so let's figure out how this is going to label. That's looking at the period. So we have 1, I'm going to spread this out this time, 2, 3, 4, 5. Okay, so we know this has to be 2 because it's going to be a period of 2. Half of that is 1. Half of that, if you want, you can put 1/2. And then half of that is 1.5 or 3 over 2. So for my cosine graph, I start here, and then here I'm going to have a point. It's going to go down underneath 1, -4, then it's going to go back up, and then end up here at 2. So that's going to be one full cycle through, and then you can just continue drawing. It bounces back and forth. Okay, so again, right here is showing period, and here is our amplitude of 4. Okay, last example, for us graphing, we are going to be applying a vertical stretch, horizontal stretch, and we remember hopefully that +3 means we're going to be translating that graph up 3. So I'm gonna start by graphing just this one, and I'm gonna do this in pencil because I'm gonna erase it after I translate it up 3. So again, 2 is going to be the amplitude. So I can already start to draw. This is gonna be 1, 2. Okay, so my graph is gonna jump back and forth between 2 and -2. Okay, then, so that's step 1, amplitude. Step 2, I'm going to find the period by using the formula 2 pi over the b value. My b value is 4, so it's 2 pi over 4, which when I simplify becomes pi over 2. So now when I label this out, it has a period of pi over 2, so I can use a marker here. 1 here, 2, 3, 4, 5. This is the period, so I'm going to label pi over 2. I know it's hard to label these, so if you don't, it's not a big deal. I'm just going to do pi over 4 because I divided that by 2 and got this. And then just don't worry about labeling those. All right, so I'm going to draw this one first. I'm ignoring +3 for a second. I'm going to draw the 2 sine 4x. So remember the sine graph is always going to be at 0, 0, and then it's going to jump up. So I have a point above this, I have a point here, down below, and here. So there is my sine. Okay, it had the amplitude of 2, and then that period of pi over 2. And then it continues on forever, okay? But we have to include this translation up 3. So what I'm gonna do is I'm gonna take each of these points and I'm gonna move them up 3. So I have to add in 3, 4, and it's gonna actually go up to 5. So this first point, 1, 2, 3. Oh, it's gonna go higher. Nope, we're good. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And that'll be good enough. So we're picturing this that we did in pencil just being translated up 3. And this is going to be your graph. That just goes infinitely up and down, all throughout. So what I would do is I would go through and erase what I did with a pencil because that's not my answer. But for our purposes of our notes, we should just leave it there just so we can see how we got to our answer. Okay, we're gonna determine the amplitude and the period of this graph and then write the equation of the graph. So we are gonna find amplitude. Amplitude is gonna be is from 0 to 1 here. So it's going to be an amplitude of 1. That's going to be part of my answer. And then the period, I'm going to look to see where this goes. So hopefully we're seeing that this is our sine graph because it's going through 0, 0. 1, 2, 3, and then 4. It's ending at pi. So my period then would be pi. All right, so with that, I shouldn't have written that right in the middle. Oh my goodness, what is wrong with my brain right now? Okay, so we're going to write an equation. So I have, I gotta write this small now, dang it. It's gonna be y equals a times sine bx. So I wrote sine because this is passing through 0, 0, so I know it's my sine graph and not the cosine. Okay, so the a value I already know. I'm going to put a 1 out in front, or nothing actually, because we don't typically put anything if it's a 1. So I'm just going to write down sine. Now I need to determine my b. So if you guys remember, so this is how we're going to find the b value. We'll do it over here. We had a formula that said the period is equal to 2 pi over b. So what I have is the period value so that I can find b. So the period we know is pi. So I'm plugging that in for period. That equals 2 pi over b. So if I want to solve for b, I would have to multiply b to both sides, and I get b times pi is equal to 2 pi. Then I'm going to divide by pi, and my b equals 2. So right here in my formula, or I'm sorry, my equation, 1 times sine 2x. So the a value is just your amplitude, which is pretty easy to find. The b value is going to take a little bit more work each time. So you find the period, and then you're going to use that to find b. Last question, and please understand if you guys are feeling overwhelmed, it's okay because this is complicated compared to other things we've done. Just keep going, and then your homework problems, there's only a few, and we'll definitely go over it when I see you Friday. Okay, so again, we're determining amplitude and period. So I'm going to see that my graph is going to bounce back equally across this 0 here. So this is my amplitude. My amplitude is 4. So I can write that here. My amplitude is 4. And then I'm going to determine the period. So the period, if I'm starting here, it's going to be my cosine graph. And it goes one full through to here, and it ends at 4 pi. So it went 1, 2, 3, 4, 5. My period then would be 4 pi. Okay, so we're now going to write the equation. So the equation, again, y equals a, and this is our cosine graph. So I'm going to write cosine of b times x. So the a value we already have. The a value is 4 because our amplitude's 4. Okay, the b value we have to find using that period formula. So period formula, again, period is equal to 2 pi over b. Okay, but we know that the period here is 4 pi. So 4 pi is equal to 2 pi over b, and we're going to solve for b. So to get rid of b here, we're going to multiply it to both sides. I get b times 4 pi is equal to 2 pi. So I divide 4 pi to both sides, and I get b is equal to, pi's cancel, 2 over 4 is 1/2. So my b value is 1/2, and I'm going to write that for b, 1/2 times x. That is my equation. All right, you guys, good job. I know this is overwhelming, so please just try your best to figure out these homework problems, and we'll discuss it Friday. Enjoy the rest of your day.